In this electric episode of FUM0044 machining, we are going to attach this one and this one to that milling machine. It requires some wiring, not a lot, and in addition it requires some logic design because especially this switch has the feed thing is how would I say, it's not simple. Well, the coolant pump, it's just an on-off switch. Same goes to the spindle, on-off. But the feed has some additional features. It has a jogging function, so you can jog with that one. And therefore we need something different for that one. So let's go on with that. Let's do a little bit of planning here. So the problematic switch was the feed switch, which has these two positions. First of all, this is the switch. Then it had 1 and 2. And when this direction, it will start running and keep on running. This direction, it will run as long as you hold the switch in this direction. Furthermore, it has a push function. When you push this switch, it will stop. Okay. Inside there, in this machine, we have 3 switches. One is the run switch. It will be closed no matter which direction you pull this, it will close that. Then we have another switch which is normally closed. And this one will, if you push this to that direction, it will open. If you push this to that direction, it will stay closed. Simple. And then we have a third switch there, which is also normally closed. And this one will open when you push the button. Okay. Then we use this switch as an activator. Then we connect these two. And there we have coming into, let's say this is ground. And then we connect this one to the ground as well. And then we have here, let's call it a keeper. Okay. Now, what we will need here is a relay. This is a coil of a relay. Then here will be plus 10 volts. And then this relay has 2 contacts. Should have 2 contacts. The other one, so when this relay is energized, these will make a contact. So these go to the VFD. And these two then, well, first of all, I will connect this to one, and then now, when you push, when you advance these to the 1 or 2 direction, it will connect. Okay, let's put the ground here. This is 0 volts. In opposed to, so it's okay. So when you close this, by turning that one, it will energize the relay and close the VFD switch, and therefore the machine runs, as was the design. Then another feature here, we connect this one to here, and this one when you put it to the direction 1, so run and keep on running, this makes it so that when the relay energizes, it will close this switch, and it will connect it to the ground through these two switches here. Yeah, and what it does, it will keep this energized no matter what you do with that switch. So when you release this, it will keep on running. When you push it, for example, so then this one opens and the relay loses its energize and the VFD stops. If you push, turn it to the two direction, this one opens and this one closes, so it is running exactly as long as you keep it on that direction. Well, at least this is our design. Let's see how it works. It should work, but you never know how these things turn out. Okay? So we need a relay for that one. Somewhere here I do have relays. There. Let's see if these are suitable. Okay. That one. That's 12 volts and has two contacts. Really good. Okay. The VFD, so we will use this one. I have a few of them there. Okay. The VFD is using delivering 10 volts. It should be enough for this relay, but let's see. I will test that one. Okay, let's start with connections. This is the relay, and I know for a fact that let me take one. That these two pins are the coil. Let's see the resistance of the coil. I'm a little bit interested on that one. The reason for that is well, it's I'm measuring with my multimeter the resistance, and it shows 690 ohms. Well, this means that for every volt you get about 2 milliamps less, but about just for simplicity. So for 10 volts it will be 20 milliamps. Okay. So let's put this power supply on. I have adjusted this to 10 volts, and now let's see what we need to look for now. These are the connections, but I know for a fact, I know from experience that the order is a little bit different than you expect it to be. So let's, this is horrible. Okay. Yeah. Okay. So when we energize it, just put the 10 volts into there, like that. If you listen carefully, this makes a sound when you hit a connection. So let's see. We need to find 2 connections here. So let's take that one first. The corner pin here. Oh, there was one. Okay, that and that will be connected when it's energized. Okay, let's see if they are still connected when I... Okay, no more connected. Good. We found one. So that pin and that pin are connected when it's energized. Now let's find another. Starting from this corner. That one is already used. This corner. I just made a connection there. Okay, nothing. Let's take that corner. Down here. Aha. Okay. There we have another. So these 2 pins and then those 2 pins. Okay, let's disarrange it. See if it is... oh, no more connected. Okay. So now we know. Now we know that... we can put these away. So now we know that this is the coil. When you put voltage on the coil, these 2 will be connected and these 2 will be connected. Okay, now so the first one goes to the plus 10. Let's use a red wire for that purpose. So I peel a little bit off from there and then I put it somewhere here. Okay, I could use my pliers here a little bit. I try to make this really neat. Okay. There you are. So, and then I just turn it a little bit there. Okay, now we have the red wire there, but it's of course this kind of connection is not very good. I'll take this also away. It's, we don't need this anymore. Well, maybe, but not at the moment. So we need to solder it. So, well, I have this type of solder. If you compare the size, no. Then I have another type of a solder. This is this is wait a minute. This is 1 kilogram. Well, it's 0.38 millimeters. Then I have this solder, which is 0.23 millimeters. Well, this is a little bit too thin. I don't want to use that. I use this one, and this is also very good. It's a, and then, well, what kind of soldering iron I have? This is my my soldering iron. This is very good. It's not hot here. It's hot there, but not too hot. So you can keep it like this. This means that the distance from where I'm soldering is really short. So, and now, if you ever do soldering, so the principle here is that you warm up the metal you are soldering. I just wet it a little bit and then you solder it. Hopefully you can see I try to. You don't put the solder into the tip. You put it into the piece you are going to solder. That is what you do. Okay. Oh, first wire there. I believe it's really, oh well, no. It's secure. Okay. Then we need to do something. So it was so that this pin and that pin will connect when you energize the relay. Okay. So I will connect this and that, and then it will go to the switches. What color? Is this good? Well, yeah, it's a really good color. And now because I need to connect those two, I need a little bit longer, like that. Oh, that was bad. Let's try again. Okay, better. And then just a little bit like that. And now what I will do here now is I need to put it there. Again, this is a little bit, you need to have at least 4 hands. Okay, there you are. Then I turn it like that. Oh, this was a little bit too long, but no trouble, I can put it like that. Turn it around there. And then this one too goes like that. Okay. And now we solder these. And again, I don't that's a good joint now. And then that one. Okay. I'm not sure about this. You need to put a little. Okay. There you are. Okay, now we have 2. And then so this one is going to the switch that always goes to ground whenever you switch it on. This one goes to VFD plus, and now we need the VFD wires. We have 1 minus there. Okay. This one is suitable for that. About that much. Please note that I'm using color coding here, because otherwise it will be really hard when you... So, that and that one will connect to the... so, what we will do, we will connect these two together, I believe. Because the minus is actually common in the VFD. We need a little bit longer. like that. Let's see how this works out. This is really soft wire. Ah, very peculiar. You need to be careful not to make short circuits here. So this one also goes to the VFD. Okay. Yes, I'm okay. There you are. Not the most beautiful joint, but nevertheless. So these two go to the VFD plus and minus. This one goes to the switch. Okay. And we still need something to the VFD. But actually we need one minus wire going to the switches. So I just made an ordinary wire here. That one goes, so this one should be soldered to there. Okay, I pre-solder it first. Well, if you wonder about this soldering iron I have, this is really not the cheapest one for the first. And the power is 50 watts on the tip. It's of course temperature controlled, so okay, so these go to the VFD. This one is pointing the wrong way, maybe. Okay, what we need more? VFD. Ah, one more to the VFD, and this is the run wire. Let's put a yellow there. Yellow is a very good color for run wire. And now and these are very special cutters. I didn't need, very special, they are magnetic. Okay, I don't need that pin, and I don't need that pin. I take them away so I don't make any connections to them accidentally. I can also clean up here a little bit. Okay. Like that. Okay, we should have 6 wires here, but we only have 5. Let's see what we are missing. So, let's see now. So this is the coil minus. No, this is the wake up. When you put this into ground, it will start running. Okay. and when you so if you connect these two with the switch, it will start running. Okay, then we should have the we made a mistake here. Okay, so this is the reason why you should have a drawing. Because here when we did this we should have the ground wire, the keep wire separate, and we are not having that. Okay, let's do it again. Well, luckily I have probably 4,000 of these relays. Now, this is a very good example what you shouldn't do when you design a thing. You shouldn't make your schematic like this. I did, and right away I made a mistake. Okay, now it's done. So here is what I have done now. So these wires go to the console switches, and these wires go to the VFD. So we have plus red, minus black, and yellow run. Then in this side we have this is this pink is run, this yellow is keep, and this black is ground. So what I will do next, I will this material is shrink tube, or whatever this is called. It will shrink when I heat it, and I will put the same thing on the other side as well. And then I will shrink them. These will shrink when they are heated. Okay. And now I have this fancy thing. This is a hot air gun. I have adjusted it to 240 degrees, and now it should I just blow some hot air here. Hopefully you can see how it shrinks. Okay, it didn't shrink a lot. I expected this to shrink quite a lot more. Okay, there you are. Didn't shrink a lot. And now, the next thing to do is to test this. Well, they are in place. Okay, and how to test this? Okay, we have here power supply, 10 volts. Again, then power supply minus. Well, it doesn't matter this case which is minus. Let's say power supply other, and then power supply plus. So this is our VFD, so to say. Okay. And then we have the multimeter here. Hopefully this one silences soon. You can hear. So when I put this here and then to the ground, there nothing happens. Okay, it's now if I the pink was the run wire. If I connect these two, that should now beep. Yep, and it opens immediately. Okay, but if I put this here, nothing should happen. If I connect these two together, like that, I will connect them between my fingers, and now it should stay. If I, yeah, it stays. It stays as long as I let this go. Yeah. Tested. Runs. Now just put it into the VFD. Well, before I put it into the machine, I should do some. This is quick epoxy. That one we don't want there. Just do a little bit mixing for that one. This is just to ensure that these wires don't make any short circuits anywhere, because this thing is going to be inside the VFD. There is plenty of room for this. There is some strange. Okay, let's see now. Let's put some of this stuff here. I think I need to do some acrobatics with this one, because now it's a little bit more. Now it's enough. And well, it tries to come out, so I need to And I will do this thing off the camera. Well, here I'm connecting the relay logic into this device. This is really easy, actually. Only 3 wires to go. So we have 10 volts here in the side, plus 10. That was the red one. Okay. Okay, I'll show you something. I already did something for these wires. Hopefully it will focus. So I have twisted them, and one mistake that people might do is to thin the wires. This shouldn't be done. It's not very good idea. Let's see if I can put it there. Okay, now it's there. Volts there. Then we need to have the analog ground, because the 10 volts is relative to the analog ground. It's they have separate power supplies in this one. The analog supply and the digital supply are separate. So we need to connect this one to the DCM, digital common. Oh yeah, there you go. Yes, and furthermore, this one should be connected to the for, meaning forward terminal. And there you are. It's connected. But now, since we need to do something here, what we need to do now is to test it. And in order to test it, we need to set one parameter differently. And the parameter is source of run commands. It should be external terminal. Yes. So parameter 001 should be set to 1. Okay. So parameter 1 set to 1. Set. There you go. Now it doesn't, you cannot run it from here no more. Doesn't go, but you can run it from here. Now when I connect these two, it should start running. And stop. And now if I hold these two together and just make a little like that, it runs as long as I keep this. Ready to go. Well, it is ready, door is closed, everything is there. Okay. Then we go here. This is a little bit tight. So this is the control panel. So this one is coolant. Okay, we need to do. Bearings are not in a good condition, I believe. And then we need to do something for those. And then maybe grease. And then this one is the feed. This is jog. And this is continuous run. Here is the variator for this. Okay, let's stop it. And this is the spindle. And here is the direction for the spindle. That switch. So everything else is alright, but this coolant pump thing, this doesn't sound good. Well, it's making an awful sound. Okay, but other than that, oh, one small, very minor thing. These screws, the threads were stripped off. I have threaded these now 3.5 millimeters, and these are 3.5 millimeter screws, but apparently they are not. First of all, I need to make them very short, and then I need to machine them. Well, a little bit fancy lathe work. Okay. So this was the electric version of FUM0044 machining, setting up the mill electronics. I consider them being ready now. In the next episode, I try to get my neighbor to help me in order to move this milling machine to its dedicated location here in my workshop. At the moment it's in a very inconvenient place, and it needs to be moved before I start cleaning and doing stuff on the front side of the machine. Back side is already done. So, till then, see you!